Welcome to a new test and teardown video. This time it's a Philips GM2877. It's a television set test generator, I think. They also call this a wobble modulator or something like that. I don't understand exactly why. It's because it can do some sweep and some mixings and it can generate the HF test signal for TV sets. And I think it works like this. If you look at the frequencies here, we got, see, this covers the entire UHF range in two of these, and see 880, and I mean it goes from 680 and then 440 to 680 and all that. But I think this is harmonics. So I think we got here 2 or 3 oscillators that is mixed together, and over here we got one oscillator that is harmonics. See, 40, 80, 160. So it's all here it's a harmonic system, and you dial this harmonic system here, and I think this is just multiplied or added to this one, and then you dial this frequency here, and I think it's simply just mixed, because there isn't any way where you select this or that or this band or this band. It's not like that. Here you select, I think, the sweep rate. Here it has something to do with how much sweep, and then the sweeper is here. Look at that. See, it says more or less sweep width, and then there's an ampli. So this is an amplifier level for, I guess, this output, and here is another amplifier level for this output. See, and HF, is that the output level for this one? I don't know exactly. Then there is a so this is probably a sweep input. You can select to have this input or not. And then yeah, what else did I see? This is of course the power on off, and X and Y output. I think this goes to an oscilloscope, and then the idea is maybe this input is also mixed or amplified to the Y output, because why do you want to have it in here if this goes to a scope? So I'm a little bit confused about the whole concept, to be honest. And there's a crystal you can put in here, and this will of course add some markers. That way you know where you are, because this is a complete non-calibrated free swinging oscillator, so nothing here is super accurate or anything like that. This one should be completely tube based. We should have 5 tubes. It should use 46 watts, and it is maybe from about 1965. There isn't a lot to see here on the back. This is the Philips service sticker, and it says it was repaired in 1981. Sometimes there's also a date up here where they say the next free repair, so it can be a year over this date somehow. I don't know. So this is a repair that has no warranty. Really weird. And that will be my serial number written here, and this should be the same number as this one. And this is a -2 model of this unit. Look at that mains plug. Luckily I got the mating connector, even with the nicely ground protection. Kind of like this extra chassis ground protective here, so this makes my work a little bit safer. Inside this fantastic Philips, the first thing I see is circuit boards, printed circuit boards. How cool is that? And that will be the voltage selector. And when I saw this, you're probably going to see exactly what I see at the same time. But I was laughing when I was looking at this this view here. I was laughing, and then I said, haha, now I know how this one works. And can you see what I was laughing about? This reveals exactly how it works. This is the backside of a loudspeaker. So this is the magnetic, this is a voice coil magnetic. And inside here, there's probably a little moving voice coil that moves a resonant part. So that will be the sweeper, the sweep oscillator is right here. And you adjust how much sweep by the amplitude of this loudspeaker. It's probably just a potentiometer in series with a filament winding or some low voltage winding and a potentiometer. I mean, that is just it. And then it moves and detunes the oscillator in here. We have another oscillator right here, and this one is connected to the frequency setting right here with all the harmonics and all that kind of stuff. And that one is using the single triode EC81 tube, a fairly rare single triode tube. In here we got the ECC88, so it's a dual triode. And again over here in this oscillator, ECC88 double triode. And that will also be one of the oscillators with all the harmonics. And you see the output from that oscillator goes down to the variable attenuator here, and then it goes into this oscillator mixer system. So this is the final stage mixing stuff, and this is of course the output from this one goes in here as well, right? The power supply up here, we got the EC80 rectifier, capacitor, and a little bit of stuff. I don't think it's doing a lot more. There's a, I think, is this 83? Yes, it is. The ECC83, a dual triode. That's right there. Big, hefty transformer. And that will be a little connector for the crystal. So maybe this oscillator is also doing, it can do both. I mean, if you plug in the crystal, it will of course oscillate with the crystal and mix that together with the normal oscillator. So this is probably why we have two triodes in this. One is the oscillator and the other one is the crystal oscillator. So that is the bottom view. And there's maybe a good reason why this potentiometer here is a big power pot. See, 100 ohm, 3 watts. And I bet this one is the sweep amplitude. And that is just why you need this big hefty winding on the potentiometer, because that goes directly to this loudspeaker sort of voice coil. That is a big inductor, probably used in the power supply for ripple rejection. And yeah, what else can I say? We got two of these attenuators. They're really used in a lot of different products. One of them can be turned, the other one cannot. So I think I will try and put in some lubrication or something like that. Other than that, I cannot turn up the signal from that one, so that is a problem. This one turns pretty fine. That will be the mains. This is okay with that capacitor. I'm always looking for burn marks, burn components, leak capacitors, if anything that prevents me or delays me from powering up. I mean, this is essential when you're dealing with old instruments like this. A good, deep going visual inspection before power up, because you can really prevent a lot of damage. So I need to open the different boxes and have a little look. So the sweep oscillator here is really easy to take out. You just have to, of course, take away the side plate. So I unscrewed the bottom of that one. And then I feel we should be able to unplug this little RF connector here. And then rotate the whole oscillator unit. So let's zoom a little bit in here on this little wobble oscillator, so you can see This is the little voice coil that makes this part move. And then there's a capacitor between these here. It's barely touching. To me, it looks like it is touching, but it is, of course, not touching. Oh my God, they made it with a tolerance that is absolutely incredible. You can't even put in a quarter of a hair here. If I hold this in the right position, I can just see a thin micron of light going through here. That is amazing design. So there's a coupling, and this is the oscillator and that tube, and here is the output. Look at that. Here's the coupler for the output. That's also quite amazing. So this is, of course, a very high frequency. Wow, what can I say? I am a little bit impressed. And then each side of this oscillator here, there's a variable capacitor here and here, and then you just tune this so it's working really good. You gotta say you are a little bit impressed. Oh, this is beautiful. I really hope this will work. But there are, again, no burnt components or anything, but there is a... What the... Look at that! Let's see if we can film that. What is going on down here? Here. This part right there. Let's see if I can get a better view of that part. So it's a 4-pin part. I really don't know what that is. So by moving this in different angles like this, you can probably see all the 4 pins going into this funny little part. What is going on there? I don't have a clue in any possible way. That is one fancy part. Maybe we should try and see if we can find some schematics or some documentations about this little oscillator unit here, and see if there is any explain. I tried to find a few schematics and manuals and all that kind of stuff, and it's just impossible to find the exact version. This is the -2 version, so I'm not able to find information about that funky part with the 4 pins. If anybody knows what that is, please tell me, because I don't have the schematic. And I really don't want to go in there and pull it completely apart. And that is the inductor for the filter for this, the voice coil. Why is it out of focus continuously? So now I put the little sweeper voice coil modulator inside again. Let's look at the other oscillator mixer box. And this one is really interesting. I will try and see if I can get a few good photos of exactly what is going on here. So again, we got the tube down here. And this is not that super interesting, but this little part here, this piece of metal that goes all the way up here, and there is a variable capacitor inside this box, and then we go back to the other part of a resonator. See this piece of metal here and that capacitor. I mean, it's quite amazing to imagine this is a little resonant circuit. Well, that is just how it is when it's really high frequencies. And how are they going to modulate and mix and all that? You see, down here is a little diode, and this is just mounted like that right next to some of these tracks right here, and this couples in here from one of the other signals that's coming right here into this chamber. But the most important or most interesting part here is this wire that connects to this diode. I think it's an OA79, and then the wire goes all the way up here, and it continues right here up to that diode and continues down here and back to the other diode. I don't know if you can see that, but that is how it is done. So by adding a signal into those diodes, they can short or affect those two resonator, and this way tune the frequency up and down. By imagine having windings, an extra winding, where the DC current in this extra winding makes the winding appear or disappear more or less. This is how it is really, and you're not even touching anything, you're just hanging over this loop, and then you create another inductive loop that you have a variable coupling degree. And this is FM modulation in 1960 something. Oh, I think it is amazing. I should probably put in a little schematic, because I found another version of this unit, and that one is using more or less the same mechanical construction and the same schematic for exactly this box. So we can look at that schematic and see how they added those two diodes on that schematic. And it's not super well drawn in the schematic or super well explained in the schematic what they do, but that is how it is. I can show it from this angle. There is a hole here at the back, and you can put in a screwdriver via a hole in the back, and then via a hole here you can get access to the trimmers in here. This one and that one up there. And so forward, there's another one here. I don't know exactly what that should do. Well, not a lot, right? Oh, over here. There's another one right there. Oh, those they go into that one. Okay, that's pretty cool. Let's look inside unit Z. This one is also the crystal oscillator and the marker oscillator, but I think it is also generating all the harmonics for this mixer here as well, right? So if we compare a little bit with the schematic, you'll see a capacitor and an inductor for the anode system, for the inductor, and there you have the other three inputs, filament input. And here is this magic 4-pin device again, and I have of course a super good idea what that is, and that is quite easy to understand. If you look at the schematic, you can see this is a 3-in-1 decoupling capacitor for all those three. So it's an integrated capacitor in size tiny. I've actually seen those a few times before, but this one is really, really beautiful. I'm a little bit sad that it's not written on it the value or anything, but that's just how it is. The crystal input is this coax cable up here, and the fun thing is, if you see that, it is a balanced 2-in-1 coax. Can you see? We got two wires coming out of it. And here is the back side of the crystal socket. You can see those two capacitors, and then the two wires that goes into this coax, the balanced coax. That is a little bit special. I don't understand exactly why they wanted to do it that way, but that is how they felt is probably better. And of course they need to shield the tubes, because you can imagine the outer part here is anode, and that is of course oscillating, and this way you emit all sorts of stuff here, but you're also very sensitive for other signals that is inside this unit. So that is why you need to have a shield on your tubes. And I believe there is a shield missing here on this oscillator here. And the socket is also, like you can see here, those little pins. Those pins lock into this type of shield. So that is, yeah, just missing. But there's not a lot more to say about the design. Now I want to try and see if it works or if it blows up or whatever happens. Oh yeah, maybe I wanted to show one little thing about this oscillator part, because we already showed the schematic. Did we? I think we did not show the schematic, and that is the problem. Because I really want to show the schematic of that one, because you can see the little loudspeaker magnetic inductor thing moving the two capacitors, as we saw when we were inside this unit. And that is really cool to see. They were able to make it that easy to understand from the schematic. And you can also see this sort of speaker coil is driven by a potentiometer and the AC filament supply. I am a little bit curious to know if I am able to see anything on the oscilloscope, because the levels here could be microvolts, usable for receivers. So I'm probably gonna go and pick up my spectrum analyzer in a minute. It's using N connector. That is also something I really like. It's a lot better connector over BNC, but here I just go to a BNC. That is just terrible. Looks like something here is a little bit wrong with that connector. Oh, this is not supposed to do that. Damn it, what happened? Is it broken? So I think this will be my first power on. I will of course put my generator in 50 ohm mode, bandwidth limit full, and then I will crank down the millivolts like that and crank up the time base, and let's see if we see anything at all. Mains is 220. This is off. Here we go, and ready or not, it is not doing a lot. So this is, oh, look. Oh, it is somehow doing a lot of funky sweepity. What exactly is? Ah, you can turn this off. You can go in sweepity spunky mode. And here is the amplitude for. It is definitely doing all sorts of funky. Oh, yo. That is one oscillator. I gotta play. Oh, can you hear this? Now you can hear the little loudspeaker in there going boo. See? This is the potentiometer that's moving the little inductor. And I will try and make a little setup here and see if we could do some sweeps and funky stuff. But it's definitely doing a lot of goody things. Wow, lucky me. And it's 34 watts. And this is how the output looks when you're poking around with the frequencies on an oscilloscope. See? I mean, it really doesn't tell you a lot about what is going on, to be honest. And there's a pretty good explanation for that, and that is definitely in the nature of how oscilloscopes works. But I will of course show another instrument in a second. Let's see if we can make this trick. So it's pulsing and it's doing its thing here, and if I change the amplitude of that sweep, we see that as an amplitude. It's actually because the frequency is moving, I guess. And then if we poke with the amplitude of the other oscillator here, you see this is that one that's moving everything, and that is the marker, I bet. And then you can probably turn one on and off like that, then nothing happened. No, I don't understand exactly. Oh, so here's only the marker. Interesting. And then what have you here? Okay, now the marker is the pulsing one. Ooh, you see that? It's also doing some funky frequency sweepy. No, it's not. So that is what we can do. Yeah, let's go and get the spectrum analyzer. This is getting boring, isn't it? I think it's a little bit difficult to show everything here at the same screen, but I think you get the idea. So this is the different modes switch. It's not super well explained what is doing what here, but it's probably explained in the manual. I don't know if you can see, it's at this little point here. I set a little line here. That means we are only playing with this oscillator here, and of course all its harmonics. And see if I dial around here, we see all the harmonics, and sometimes also some weird things happens. Maybe it's because it's just a little bit of mechanical stuff that's going on. So let's just put it right here where we have two good strong peaks, and I can measure. This one is 944 megahertz, so it goes quite high. And funny thing is that nothing here on this scale matches that frequency in any possible way. So let's try the other scale. If we go to the one click to the left, I believe now it's this one. So if I play here, I don't know if you can see some pulses. No, not really. Is it still this one? I don't know if exactly what's going on right there. Maybe this is the crystal oscillator. So I put in the crystal, no. That I don't know. But to the left here, I have everything. Both this oscillator and this one merged together like that. And see, I can move. I don't know exactly how I move. We can turn up this. Okay, here we go. And then I don't know exactly what we're doing here. I don't really see what I wanted to see. Yeah, see some of them. Aha, here we go. All these are moving, but note that one is not moving. So that one is the one that comes from. No, it is not. So this is a magic unit, and here is that one. Maybe. Ah, that is the modulator thingy. So now this is my here, and it adds modulation. You can maybe hear this little hum. I turned up the modulator potentiometer right here. This is the little voice coil that moves, and now this one is doing this sweep. How cool. And it is of course modulating or mixing to some of the others. I could also turn everything on maybe. No, these are not modulated. I don't think I understand the true nature of this one, because some of them are moving while others are not. Why do you want that possibility? So here is the modulator, and it's turning on and off all the time, and I think this is because it is in synchronization with a mains frequency, and my sweep here is not locked to a mains frequency, so that could explain why it appears to have this low frequency blinking, but it's obviously a interference sampling thing. But let's try it now and slowly crank up the voice coil modulator. See, here is a little bit,
and then I can give it more and more, and here is maximum. So this is definitely a funny mechanical modulator, and again, the reason for this to look like this is because my sweep is not. By changing the sweep times, I was able to prove this point about this blinking trace, and now we will try and crank up the modulation again, and we can definitely see what is going on. Anyway, I don't think there's a whole lot of more I want to show about this unit. I think it was fun to play with this funny old oscillator. So thank you very much for watching. Bye bye.